Welcome back to The Explainer. Today, we're diving into a massive, monumental shift in the financial technology landscape. Let's just state the obvious right up front. Legacy screen scraping, that clunky, super insecure method of essentially logging into bank accounts on behalf of users, is officially dead. Good riddance, right? So, what replaces it? Well, today, our goal is to build a modern, highly secure financial data aggregation platform. We're going to construct a 2026-ready digital fortress, layer by layer. To keep us on track, we'll use this agenda as our mental roadmap. We're going to start with the shift to API aggregation, lay down our cloud-native foundation, build out the microservices nervous system, install some heavy-duty OAuth security doors, and finally bring in the compliance inspector. Let's get building.
All right, starting with Section 1, the era of API aggregation and the end of screen scraping.
We really have to appreciate the fundamental shift away from legacy credential sharing because it's completely reshaping global finance. For years, screen scraping was the standard. But think about what that actually meant. We were pulling unstructured HTML, forcing consumers to hand over their highly sensitive passwords, and suffering through agonizing 5 to 30-second response times. It was incredibly fragile. The connection broke every single time a bank simply updated its website UI. Enter open banking APIs. Driven by major regulatory frameworks like Europe's PSD2 and Section 1333 in the US, APIs give us structured JSON data, secure OAuth tokens instead of shared passwords, and lightning-fast responses in under 500 milliseconds. It's a completely different ballgame.
Now, you might be wondering, how do you actually plug into this new ecosystem? You basically have two choices, direct integration or an API aggregator. Consider this. Building a direct integration gives you maximum control, absolutely, but it can easily take 4 to 8 weeks per bank to build. Plus, you have to meet every single bank's unique specifications. On the flip side, deploying a unified API aggregator, think Plaid or Yodlee, can be done in just 1 to 2 weeks. It dramatically accelerates your time to market, even if you do have to factor in per-user fees.
Moving on to Section 2, Cloud-Native Distributed Tech Stack, the foundation.
Okay, let's head down into the basement of our digital fortress. We need to lay a foundation capable of handling up to 1 million queries per second without even breaking a sweat. At the heart of this foundation is distributed SQL. If you're building a modern fintech stack, you absolutely demand this. It perfectly combines the familiar relational model and strict ACID guarantees with horizontal scalability. Why is this so critical for your fortress? Because it entirely eliminates single points of failure. Seriously, even if an entire cloud region literally goes offline, your multi-row ACID transactions remain completely durable, and your system stays up. Your financial ledgers simply cannot afford to go down, and this ensures they won't.
And the great thing is, you have brilliant flexibility in how you deploy this foundation. You can use a managed DBS, database as a service, to just offload all the annoying patching and maintenance. Or you can go self-managed for total, absolute network control. Alternatively, you can use a hybrid and multi-cloud approach to drastically reduce your vendor concentration risk. But here's the most important part. Modern platforms use geo-partitioning to enforce strict data residency. That means you can keep European data in Europe to easily handle GDPR and hit your PCI DSS compliance seamlessly, right at the database layer.
Up next is Section 3, Events-Driven Microservices with Kafka, the nervous system. Let's take the elevator up to the processing and streaming layer. This is where the real-time magic actually happens. Just look at the explosive, continuous growth in data volume across the collection, processing, and structured data modules. It's wild. When you're expected to handle a daily call volume in the billions, and you absolutely need a 99.999% fault tolerance rate, traditional batch processing simply collapses under the weight. You need an architecture that is built from the ground up to stream. And that brings us to Apache Kafka. Recent research beautifully frames Kafka and event-driven microservices not just as some dumb data pipeline, but as an organizational nervous system. I love that phrasing. It means your fintech platform isn't just sitting there passively storing data. It's continuously sensing, deciding, and acting in real time. Whether it's spotting fraud instantly or updating an account balance the second a transaction clears, microservices communicate instantly, ensuring your digital fortress is always awake and highly responsive.
Let's jump to Section 4, Securing APIs with OAuth, the security doors.
We're moving out to the integration layer now to install our robust security doors. We're using financial-grade API, commonly known as FAPI and OpenID Connect standards. Now, securing these connections basically requires 5 crucial actions. First, you register your app to secure a unique client ID. Then, you establish the client credentials grant. That's for those really critical server-to-server automated processes. Next is the authorization code flow, which secures user consent dynamically with frameworks like PKCE. After that, you carefully exchange that code for short-lived access and refresh tokens. And finally, you guarantee secure access by reliably passing that token in the HTTP authorization header. This entire flow ensures that actual user credentials are never ever exposed to your app.
Now, I want to issue a very, very critical warning here. Honestly, I'd shout this from the rooftops if I could. Never hard code your credentials. It is the most common pitfall out there, especially when we're talking about mobile apps. Embedding client secrets directly into your application code is a massive, unnecessary vulnerability. Always, always use environment variables. Or if you want maximum security, which you should, store your refresh tokens in hardware security modules, or HSMs. You might be wondering why I'm emphasizing this so heavily. Well, because over 50% of API breaches stem directly from authentication and authorization issues. 50%, half of all breaches. To lock this down even further, the industry is quickly moving towards advanced flows like PAR, which is pushed authorization requests, and SIBA, which actually separates the device initiating the transaction from the device authenticating it. These aren't just fancy buzzwords, folks. They are the heavy vault doors of your digital fortress. Finally, Section 5, Mastering Financial Compliance Checklists, the Building Inspector. We've arrived at the very final layer of our architectural blueprint, the Building Inspector. This is all about the strict regulatory audits that basically wrap our entire system in a tightly woven security blanket. Take a look at the core expectations from the December 2025 FISC checklist. What you'll notice is that this isn't just about the code. It is incredibly holistic. It covers computer facility management, physical office security to prevent unauthorized people from just walking in, rigorous system development and ops, and of course, strict API access control. A major takeaway here is parity. Regulatory bodies expect that the API connection partners, the fintechs, maintain an authentication strength that is strictly equal to that of the primary financial institutions themselves. Simply put, there are no weak links allowed. Which brings us to the end of our explainer today, and I want to leave you with this somewhat provocative question. Is your platform just barely surviving the data flood, or is it truly engineered to stream, secure, and scale? Because remember, a failure at literally any single layer, whether it's an outdated database, a slight bottleneck in your event stream, or one loose OAuth token, completely compromises the entire fortress. I highly encourage you to apply this 2026 blueprint to your own architecture. Keep learning, keep building securely, and I'll see you in the next explainer.